Welcome to our practice test on Chapter 9, Solving Quadratic Equations. Guys, so many of these problems can be done in multiple ways. I'm going to choose the way that I think is the fastest or the most effective way, but I will mention the other ways that could be solved. So number 1 says solve x squared minus 6x minus 27 is equal to 0. Guys, in this case, I would try factoring. I see all three sections, the A, B, and C. And because there is no leading coefficient, I would at least try factoring. So when I start this problem, I look at 27 and I say, what are the factors of 27? Well, I can get 1 and 27. 2 doesn't work, but 3 and 9 works. 4, 5, 6, 7, 8. None of those work. Because it's negative, something's negative. And then I look for the pair that adds up to get me negative 6. Well, I find a pair that adds up to get me positive 6, so that tells me it's the right pair. I just need to change the signs on it. So that means the factors here would be x plus 3 times x minus 9 is equal to 0. So now using the zero product property, that tells me either x plus 3 is 0 or x minus 9 is 0. And then solving, I would subtract 3 from each side and get x could be negative 3. And over here, I could add 9 to each side, and I would get x is equal to positive 9. So my two solutions here are negative 3. It should be the set here, negative 3 and 9. Those can be in any order because it's not an ordered pair. It's just the set of numbers that are a solution. Now this equation could very easily be solved using the quadratic formula because remember the quadratic formula works on every single problem. Number 2 says solve 2x squared plus 7x minus 4. Now on this one, we could try factoring, but because there's a leading coefficient, that tells me I'm going to have to use the AC method. So you could absolutely do that. This one actually is factorable, but I personally would probably try quadratic formula in this case. So I would start by figuring out my A, my B, and my C. In this case, A is 2, B is 7, and C is negative 4. And then I would go with the quadratic formula, which says x equals opposite of b, so negative 7, plus or minus the square root of b squared. So 7 squared would be 49, minus 4 times a, which is 2, times c, which is negative 4, all over 2 times a. 2 times 2 is 4. Now, I would use my calculator here to figure out what the square root of 49 minus 4 times 2 times negative 4 is. And I find out that that answer is 9. So negative 7 plus or minus 9 all over 4. At this point, I would then say I'm going to split this apart into two problems. So negative 7 plus 9, that's 2 over 4. And negative 7 minus 9, that's negative 16 over 4. And then the last step, I would just simplify each one of these. 2 over 4 becomes 1/2, and negative 16 over 4 becomes negative 4. So my two solutions are the set of numbers 1/2 and negative 4. And again, those can be in any order. This one is actually factorable if you wanted to use the AC method. Number 3, again, I look at this one. It's not equal to 0. So the first thing I'm going to do is subtract 84 from each side so that I can take a good look at this in quadratic equation. And I get x squared minus 5x minus 84 is equal to 0. Now I see there are 3 terms here. This is not one I can use my square root method on. But because there's no leading coefficient, it might be one worth looking at for factoring. So I'm going to go ahead and list my factors of 84. And I get 1 and 84, 2 and 42, 3 and 28. I'm out of space here. 4 and 21. 5 doesn't work, but 6 and, let's see, 84 divided by 6, 6 and 14. And then 7 and 12. And because it's negative, something's negative, so I'm putting my negative sign, and I'm looking for a pair that gets me negative 5. So none of these seem to work. Oh, there's one that works. But that one gets me positive 5, so I'm going to switch my signs and make this one now be the factors x. Let me come over here where I've got space. X plus 7 and x minus 12 as solutions, as factors, which means then x plus 7 could be 0, or x minus 12 could be 0. And solving then, I get that x could be negative 7, or over here I get that x could be positive 12. So the two answers I get are negative 7 and 12. Again, this one could be, you could use the quadratic formula on this one. It wouldn't be too hard to try that out as well. All right, coming to number 4, it asks for the solution. Again, guys, when I look at this one, it's not equal to 0. So the first thing I'm going to do is move that 11 over and get x squared minus 6x minus 11 is equal to 0. And then typically I would try factoring here. However, because this is a multiple choice question and I see what my answer choices look like, a factoring problem will never have square roots in the answer. And so this tells me it's not factorable. And so I'm going to go ahead and just go straight to the quadratic formula. So on this case, A would be 1, B would be negative 6, and C would be negative 11. Remember, A, B, C. So quadratic formula says x equals the opposite of b. So since b is already a negative 6, I'll make it a positive 6, plus or minus the square root of b squared. So negative 6 times negative 6 is a positive 36. Remember, that first number will always be a positive. Minus 4 times a, which is 1, times c, which is negative 11, all over 2 times a, which is 2. Now I can go ahead and try the square root of 36 minus 4 times 1 times negative 11, but I already know that it's going to give me a decimal. And so because my answers are in exact form, not decimal form, I'm going to just figure out what that number is, 36 minus 4 times 1 times negative 11, and write that down. So I've got now 6 plus or minus the square root of 80 divided by 2. Again, because of the form that my answers are in, I'm going to take that 80 over here to the side and I'm going to simplify using birthday cake method. So I'm going to divide by 2 and get 40. Divide by 2 again and get 20. Divide by 2 again and get 10. Divide by 2 again and get 5. Finally, divide by 5 and get 1. Remember, this is the prime factorization of 80. And because it's a square root, I'm looking for pairs. I see 2 pairs of 2, so 2 times 2, that would become a 4. And the 5 without a partner has to stay inside the radical. So 4 square root 5. So I'm just going to rewrite this problem now as 6 plus or minus 4 times the square root of 5 divided by 2. And then because the 2 can divide into each of these evenly, I'm going to simplify and say that this is 3 plus or minus 2 times the square root of 5. And I get then that my answer is choice A. All right, moving on to number 5. There's 2 ways of looking at this one, but what I notice is there's no bx term. Because there's no bx term, that means the square root method will work, and I like to use the square root method if possible because it's fast. And so the first thing I'm going to do is rewrite this problem, getting the x squared all on its own. So I'm going to add 47 to each side. And when I do that, I get x squared is equal to 59 plus 47, which is 106. Now, I need to read carefully here. It says round my answer to the nearest hundredth, so they're going to be totally fine with fractions and decimals here. So I'm going to take the square root and just use my calculator then to take the square root of 106. And I get 10.2956. This says round to the nearest hundredth. So 10.295, I go 3 places and that 5 tells me to round up. So this actually becomes 10.30 as my answer. And I don't want to forget, because it's the square root method, I need two answers, so we've got to remember that plus and minus in the front. Number 6, again, quadratic equation. Because of the type of answers that I have here, they're not nice whole number answers, I'm going to go straight to the quadratic formula for this problem. So quadratic formula starts with finding my A, my B, and my C. In this case, my A is 1, my B is 14, and my C is 44. And I'd start with x equals the opposite of B, negative 14, plus or minus the square root of B squared. So 14 squared, that's 196, minus 4 times A, which is 1, times C, which is 44, all divided by 2 times A, which would just be a 2 here. So using my calculator, since this can be a decimal, I'm going to take the square root of 196 minus 4 times 1 times 44, and I get an answer of 4.47. So I'm going to have negative 14 plus or minus 4.47, all divided by 2, and then here's where I split it up. So negative 14 plus 4.47 would become negative 9.53 divided by 2. And then negative 14 minus 4.47 would become negative 18.47, also divided by 2. And last but not least, do that division and I get negative 4.76 and negative 9.24. Now, when I look at those two answers, I don't see those exact answers, or actually I do see those exact answers over here, but I've got to be very careful because there are some very similar answers. So I want to make sure that I'm looking at signs very carefully. So I want both of them to be negative. In this case, that looks just like letter A. As I do this problem, though, guys, if you round in a little bit of a different place, you may get something that looks just a little bit different, but it still can work. You just need to look for the best possibility with this, even if your rounding is just a little bit different. Number 7 says solve the following, give an exact answer, and it's an x squared minus 54 is equal to 0. Again, since I noticed there's no bx term, I'm going to use the square root method on this one. Absolutely could use quadratic formula, just noticing since there's no b term, we'd put a 0 in for b. But I think square root's a little faster, so I'm going to start with 3x squared minus 54 is equal to 0. I'm going to move that 54 over to the other side because my goal here is to get x squared by itself. So 3x squared is equal to 54. Then I'm going to divide by 3, and I get x is equal to 18. X squared is equal to 18. All right, now that I've got x squared by itself, I need to work on getting the x by itself, so I'm going to introduce a square root. And when I try the square root of 18 in my calculator, I get a decimal. And so because they asked for the exact answer here, I'm going to have to come over and do birthday cake on 18. So 2 goes into 18 9 times. 2 doesn't work anymore, so I try 3. 3 goes into 9 3 times, and 3 goes into 3 one more time. And so now I see a pair of 3s, so that comes outside, and what has no partner stays inside. Don't forget the plus or minus with the square root method. So my two exact answers on this one are 3 square root of 2 and negative 3 square root of 2. Number 8 says, what is the discriminant? That's that special part of the quadratic formula that tells us how many answers we're going to have. And the discriminant is just the part that says b squared minus 4 times a times c. So in this case, I'm just going to start by writing down my a, my b, and my c. A is 2, b is 3, and c is 4. And so b squared, 3 squared would be 9, minus 4 times a, which is 2, times c, which is 4. And I end up getting 9 minus 32, and 9 minus 32 is negative 23. And so when I get a negative discriminant, that tells me this problem would have no solutions. Remember, a discriminant that's positive tells me two solutions. That's what we're used to having. A discriminant that's 0 tells us there's only one solution, and a negative discriminant tells us there's no solution. Number 9 says the solutions of a quadratic function are 9 and negative 4. So which of the following could be the function that we're talking about? Guys, there's a couple of ways that we can approach this one. Number 1, we could solve A, B, C, and D and find out which ones have solutions of 9 and negative 4. But we could also look at this one and say, well, 9 and negative 4, that means x minus 9 and x plus 4 are going to be the factors, and we could FOIL or use box method to multiply backwards. Either way works just fine, but I'm going to go ahead and start by looking at factors on each one of them and see if I could figure that out. So because they end in 36, at least the top 3, I'm going to go ahead and just list the factors of 36 here. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. All right, on the first one, it's a positive 36. So either everything's positive or everything's negative. And so I'm looking for a pair that adds up to get me negative 5. And quite honestly, I don't see a pair that adds up to get me negative 5 if everything is positive or negative. So I don't think A is going to work. When I look at B, it's negative 36. So that means something's negative. So I'm going to put a negative in front of everything and look for a pair that gets me to positive 5. And there's my pair, which would tell me on part B that x minus 4 and x plus 9 are factors. Well, guys, according to the zero product property, that would mean that x minus 4 is 0, which would mean x is positive 4, not negative 4. This one's a little tricky. And x plus 9 is equal to 0. That would tell me x is negative 9, not positive 9 like I'm looking for. So B is also not a choice. Now C looks very similar to that last one, except I'm going to switch my signs to get a negative 5, and that right away tells me I think this is the one we're looking for. X plus 4 is 0, or x minus 9 is 0. And when I solve this, there's where I get my x equals negative 4 and my x equals positive 9. So it looks like C is a good answer. Now, since this one says select all that apply, I want to go ahead and look at answer choice D. And answer choice D at first glance looks like not a very fun problem, so I could use quadratic formula on this. But I also notice that everything looks like it ends in 5 or 0, so it might have a greatest common factor of 5. So when I do that, I take that 5 out, and I'm left with x squared minus 5x minus 36. And I notice that that's exactly the same thing as problem D, which means this would factor into x plus 4 and x minus 9, which means it would have the same solution. So in this case, D would also work. All right, last two problems deal with our modeling. So this one says, what's the maximum height reached by a ball thrown from a building 25 feet high using the following equation? Negative 16t squared plus 32t plus 25. And so the key word here is maximum height. Maximum height tells me I need to find the vertex because that's when it will be at its maximum. And so vertex we find by taking x equals the opposite of b divided by 2a. In this case, b is 32, so the opposite would be negative 32. And a is negative 16, so 2 times negative 16 would also be negative 32. And when I divide, I get an answer of 1. Now remember, that's only half of the vertex. And so to find the other half, I need to plug in 1 to my equation. So negative 16 times 1 squared plus 32 times 1 plus 25. When I plug that into my calculator, I end up with an answer of 41. And so what this tells me is it takes about 1 second to get to 41 feet. So the maximum height in this case would be 41 feet. And finally, question 11 says, when will the ball hit the ground? Guys, remember, we take this and we shoot it up in the air and then it comes down, and we talk about when will it hit the ground. It will hit the ground at a solution. So a solution would be either factoring, square root method, or quadratic formula. In this case, because of the problem type, I think quadratic formula is our best option. So x is equal to the opposite of b, negative 32, plus or minus the square root of b squared. So 32 squared, that's 1024, minus 4 times a, which is negative 16, times c, which is 25, all divided by 2 times a. 2 times negative 16 is negative 32. Again, word problems, because we're talking about time, that can be a fraction or a decimal. So we'll go ahead and figure this out. Using our calculator, we'll take the square root of 1024 minus 4 times negative 16 times 25, and we get an answer of 51.22. So I have negative 32 plus or minus 51.22, all divided by negative 32, and here's where I split it up. If I take negative 32 plus 51.22, I get 19.22 divided by negative 32. And if I take negative 32 minus 51.22, I get negative 83.22, all divided by negative 32. And then finally simplifying, I get negative 0.60, and I get 2.60. Guys, a negative answer in this case doesn't make sense because I wouldn't talk about the past when the ball is hitting the ground. So I would say it will take about 2.6 seconds for the ball to hit the ground. Guys, I hope this helps. The answer key that's posted on Google Classroom does have the other options. So if some of these problems you chose not to factor, you chose to use quadratic formula, you'll see the work on the practice test for that method as well, even though I didn't go over those on this video. If you have any questions, make sure you stop by and see Mr. Jordan or myself, and we'll be happy to help you out. Have a good day.